Do you really know what people mean when they say a programmer should understand the fundamentals? Is knowing the syntax of a programming language enough? Or do you need to go beyond that? If you're given a project with multiple modules, classes, and data structures, can you quickly figure out what's going on? Or if a complex bug appears that can't be solved with simple debugging, can you trace it back to the root? One, algorithms and time complexity. Anyone can write a for loop, but not everyone understands why a program sometimes runs slowly. Understanding time complexity Big O is one of the most fundamental concepts you must master. Sorting. The difference between bubble sort, merge sort, and quick sort isn't just in their names. Execution time and memory usage vary. Searching. Linear search versus binary search. Without knowing the array must be sorted first, you can't choose the right one. Time complexity. You need to know exactly what O n log n means and how it affects your program's behavior. Always analyze your algorithm, even if it gives the correct result. In technical interviews, understanding algorithms matters more than knowing the syntax. Even the simplest algorithm can slow things down if used incorrectly. 2. Object-oriented programming. Many people know what a class and object are, but they don't understand why we use OOP. If you can't explain the difference between inheritance and composition, you've still got work to do. Encapsulation. Hiding data to make your code more secure and structured. Inheritance versus composition. Inheritance isn't always the solution. Composing classes can offer more flexibility. Polymorphism. One interface, multiple implementations. This makes your code more extendable and testable. Whenever a class starts getting too big, it's time to break it down. Use solid design principles like SOLID. Good OOP keeps your code modular and maintainable. 3. Architecture and modular design. Structure in software design isn't just about aesthetics. If your program grows without a solid foundation, it will collapse like a building without pillars. Separation of concerns. Each part of the program should have only one responsibility. Dependency injection. To separate dependencies and make testing easier. Layered architecture MVC. Splitting the program into model, view, and controller layers simplifies development. Every file should do just one thing. Too many dependencies between modules is a sign of poor design. Good design starts before writing any code. 4. Data structures. Many have heard of lists, dictionaries, or arrays, but truly understanding when, where, and why to use each one is a whole different level. Data structures are your most essential tools for solving any problem. Lists and arrays for ordered data. Know the difference between an array and a linked list. One is faster for access, the other better for insertion. Stack and queue. LIFO and FIFO structures. Very useful in algorithms like backtracking or BFS. Hash table. For fast key-based access. You should understand how collision handling works. Tree and graph. It's not enough to know trees have parents and children. You need to understand and implement algorithms like DFS, BFS, or even Dijkstra. Before choosing a data structure, always consider the type of operations. Search, add, delete. Evaluate both memory and time, not just speed. The right data structure can turn an unsolvable problem into a solvable one. 5. Testing and debugging. Writing code without testing is like driving without a seatbelt. And debugging isn't just throwing in some print statements. Unit testing. Testing small units like functions with clear inputs and outputs. Integration testing. making sure different parts of the program work together correctly. Debugging tools, using interactive debuggers, breakpoints, and professional logs. Good code should be testable. Never trust code that isn't tested, even if it works. Learn tools like the VS Code Debugger or Hobbyist. Each of these core concepts is a pillar of professional programming. Each of these core concepts is a pillar of professional programming. Someone who understands them not only writes better code, but also solves problems faster, understands others' code more easily, and performs better in large teams.